Chapter 21 is all about solutions. So we've now seen how atoms are bonded together to form compounds in order to achieve a stable electron configuration. We've also seen how chemical reactions can create new chemical bonds or break chemical bonds. So now this entire unit is all about using all of this information to make chemistry usable, right? Something that we can actually use and make products with that can affect our lives. So, first part is solutions, then we'll talk about acids and bases, and then we'll talk about carbon chemistry. So, a solution is a homogeneous mixture of typically water and a solid, but that doesn't mean that that's the only type of solution. Remember that word homogeneous means that it all looks the same. It looks like a single material. But we can have homogeneous solutions in the solid state and in the gas state. So we got some vocabulary terms we need to understand. So solute is the material that is being dissolved. Solvent is what does the dissolving. Typically, it's the larger amount. An alloy is a metallic solution, right? This would be a solid state mixture. And in order to create an alloy, you first have to melt all of the metals to be involved. So some typical alloys would be like stainless steel, which is a mixture of iron, carbon, chromium, and nickel. But it looks like a single material. When you have a solid solute and you put it in water, especially if it's a polar or an ionic material, when an ionic material dissolves in water, water will surround the material, and the negative oxygens will be attracted to the positive cations. The positive hydrogens will be attracted to the negative anions. And so they'll start to pull apart all of the ions in the ionic compound and then surround those ions with water to prevent them from forming back as a solid. Okay, so here we have an example of an ionic compound. Water comes in and starts to pull it off. So the negative oxygen is attracted to the positive metal part of the ionic compound here. The positive hydrogens are attracted to the negative nonmetal. And so now this leaves space for more water to come in and attack. And then those ions end up being protected by a bubble of water. We call it a hydration shell, and that prevents it from coming back into a solid state. We can affect the rate of dissolving by changing a couple of things. When we want to get something to dissolve faster, we can crush it or grind it up to increase the surface area, meaning that there's now more space for the solvent to attack and disperse the solute. Stirring allows the solvent to hit the solute more, allowing it to dissolve faster, and increasing the temperature. So increasing the temperature is going to mean that those solvent particles are moving around more and they can attack the solute and dissolve it more. If we have materials that, like water, we call that a polar material. Polar materials will dissolve polar materials. So you might hear the phrase like dissolves like. Polar will dissolve polar. Nonpolar will dissolve nonpolar. Nonpolar solvents are things like acetone, alcohol, oils. So we can use them to dissolve things, but a lot of times they can be toxic or flammable. So we try really hard not to have to use organic or nonpolar solvents. Concentration is a measure of the amount of material that is dissolved, so the amount of solute compared to the amount of solvent. We have a couple of ways to represent this. Percent volume would be if you have a liquid dissolved in a liquid. For example, this isopropyl alcohol right here, 70% is isopropyl alcohol. That means that the other 30% is water. If we have percent mass, that's typically a solid material dissolved in a liquid. So 0.9 sodium, 0.9% sodium chloride. That means the other 99.1% is water. And then molarity is the more common unit for scientists. It's the number of moles of solute divided by the volume of solution. So concentration is going to tell us an actual number. So percent volume, percent mass, and molarity tell an actual number. But we can describe things as being concentrated or dilute. And this has to do with, this is a more subjective kind of understanding of what's going on. So concentrated means that there's just more of it. So this would be a very concentrated solution. Whereas this would be a very dilute solution because there's less of this red color. Okay, so as the red intensity increases, we would say it becomes more concentrated. This graph shows a picture of a solubility curve. Solubility is the maximum amount of material that can dissolve at a certain temperature. So this curve compares the mass of solute that dissolves to the temperature. And so we can determine whether something is going to dissolve if we have, say, let's say we have 40 grams of potassium chloride at 30 degrees Celsius. So we'd say 40 grams at 30 degrees. And we see here's the potassium chloride up here. And without doing any kind of work, it's not all of that is going to dissolve because it's above this line. If it ends up on the line, like right here, if we had 15 grams of the K2CR2O7 at 30 degrees, then yeah, that would all dissolve. And so we can talk about our types of solutions as being saturated, unsaturated, or supersaturated. Saturated means it has exactly as much as it can hold. You can't put any more in there and have it still dissolve. Unsaturated means it could still hold more material. You could continue to add solid solute and it would still dissolve. Supersaturated means that it has more material than you would expect. And these are unstable, meaning if you shock it somehow, it's going to recrystallize. In order to form a supersaturated solution, you must heat it for all of the material to dissolve. So there's a really cool video of a supersaturated solution right here to watch. Now, we've talked about how solubility of solids can be increased, but we can also dissolve gases into liquids, into solution. And in order to increase the solubility of a gas, we can increase the pressure, meaning that there's now less space for these particles to move around. So if we increase pressure, they now move around less. So they're going to get stuck in the liquid. And the same is true if we decrease the temperature. So decreasing the temperature means that they're moving around more slowly. They're going to stay in the liquid phase more. An electrolyte is a material that produces ions in solution. Electrolyte sounding like electricity. So an electrolyte can carry an electric current. We can have strong electrolytes, which completely ionize. So that would be like salts. We can have weak electrolytes, which only partially ionize, like a weak acid or a weak base. Or we could have a non-electrolyte. A non-electrolyte is a material that will not produce ions when dissolved, and it will not conduct electricity. When we have an ionic compound and a covalent compound, they're going to dissolve in different manners. Covalent compounds will go through a process called ionization. So, ionization sounds like making an ion. So, it's a material that is not ionic, but when dissolved, does form into ions. So, covalent compounds are pulled apart to become ions. And typically, this is a highly exothermic reaction. In dissociation, ionic compounds separate into their individual ions. But we also have materials that don't form ions, right? We have non-electrolytes, but they can still dissolve. So they dissolve through a process called dispersion. So dispersion is how materials like sugar will dissolve. They just spread throughout the solution. Again, there's a great video here to watch about dissolving. When we have a solution, the properties of the solution change. Typically, water has a melting point of 0 degrees Celsius or a freezing point of 0 degrees Celsius. But if we put a solute on there, on ice, it's going to change the melting point. This is called freezing point depression. By adding a solute, we can actually lower the freezing point of water. So instead of freezing at 0 degrees Celsius, maybe it freezes at negative 15 degrees Celsius. This is why we put salt on roads when it gets icy. The same is true for boiling point. The boiling point is going to increase. So now it has to be hotter to boil. So boiling point increases. And this is why we put radiator fluid in our cars. Radiator fluid is going to boil at a much higher temperature than just straight water. And when we have more ions, there's a greater effect. So you're going to complete that work page, and when you finish, you'll submit chapter 21.